And we're back with more about the global circulation, and there's a lot of good stuff to share here. It's in the book. You got a great book. Good thing you got a great book, but it kind of needs a little extra explanation. So anyway, I've left up here a picture that shows the global circulation as we left it off with the three-cell model. This is the one where you had the intertropical convergence zone / doldrums. We have the trade winds. We have the horse latitudes, aka subtropical high pressure system. We have the westerlies. We have the subpolar low, the polar easterlies, and the polar high. And we have these circulation cells, kind of small here, I guess, to see. But basically, over the intertropical convergence zone, we have rising air. In fact, that leads to frequent thunderstorms near the equator. It's actually a thing. Oh man, we could be using the Omni Globe about now, but I don't have an Omni. So anyway, so you get these rising air currents and clouds and rain here. That's kind of what should happen. And then the circulation breaks off, goes this way, and there's some subsiding here. This is a little mixed up in this area. Don't get too upset about that. Anyway, air is subsiding down this area of high pressure, so it tends to be dry here. And then you get up to the low up here, it's going to be kind of rainy again where there's rising air. And then the poles should be fairly dry. So I'm really about to describe first an idealized version of it, which is approximately true, and then we'll finesse it and make it more accurate, of the way the world's precipitation patterns work. It's a big world, and people live lots of different places, and their lives are governed, largely by the patterns of rain, drought, and everything. And we're about to learn how that stuff works. This is, I think, practical stuff to see what life is like in other places and to understand a theoretical basis for it too. All right, so what I'm going to do is draw like another little piece of Earth over here and an equator in the same sort of zone thingies. By the way, these latitudes, it's worth saying something about just what they are. Roughly speaking, well, of course, the intertropical convergence zone is around 0 degrees latitude. The poles are, of course, 90 degrees latitude, 90 degrees north, 90 south. These latitudes are approximately, I'm going to use the number 28 here. It's not exactly that, but it's 25, 30, somewhere in there. And this is approximately 60 degrees north and south. And these aren't temperatures, they're latitudes, okay? So roughly speaking, our zones break up about there. That's about where this three-cell circulation breaks up. Incidentally, we started with a one-cell thing, and that was naughty because if the wind blew from the east everywhere and stopped the Earth from rotating, you can't have that. So we had this broken up thing with an in-between cell to make up for it. Funny thing happens. If you have a planet that spins faster, it can break up into more cells. I don't know a whole lot about modeling the atmosphere of other planets. I do know this, connecting with astronomy here. Jupiter, I've looked at Jupiter lots of times. Jupiter's got a whole bunch of parallel latitude line cloud belts. It's got like several in each hemisphere. It's because Jupiter spins really fast and has strong winds, and the Coriolis effect is bigger, and it makes it break into more cells. It's kind of fascinating how weather can happen on different planets. A very slowly spinning planet could have just one big cell. There's some evidence Mars, actually, even though it spins pretty fast, doesn't have this cell pattern, but Earth does because of our conditions. Anyway, so theoretically, what would you expect in terms of wet and dry? You would expect low pressure to make it wet. So as a very first approximation, the equator should be wet. Kind of is. It's where a lot of tropical rainforests are, near the equator. Across, unfortunately, this globe doesn't have the landform. It's just got different colored countries. But I can tell you that there's rainforest through here, that area. There's rainforest across Central Africa. This area in Southeast Asia is real rainy, and there in Indonesia, even a little bit of northern Australia, all through there is wet. It's true, it's largely wet. And then you would expect high pressure to be dry. You'd expect dry places at around 25 to 30 degrees from the equator in each hemisphere because that's subtropical high. And you know what? It's largely, not quite completely, but largely true. You know what? There's desert in southwest Mexico there, that area. It's kind of the edge of that range. Yeah, the Sahara Desert right in there. And then Saudi Arabia, maybe not India quite so much, not so much there. But there's deserts in several places that latitude. And in the southern hemisphere, Australia, the red center of Australia is largely desert. And it's not quite desert here, but it is here. So it's largely, not completely true, that deserts tend to form around 25-ish, 28, 30 degrees either side of the equator. And then you'd expect conditions to be relatively wet, around 60 degrees. It's true that that's a cloudy, stormy region. Now, there's not that much rain there or snow because it's kind of cold and the air can't hold, all that much moisture. But it is a cloudy, rainy-ish, stormy kind of region, the subpolar low region, like the Aleutian Islands, Iceland, places like that. Down here, just the southern tip of South America, it's stormy and cloudy a lot. And then you'd expect the poles to be dry. Now, most people don't go to the poles. Wouldn't know if they were dry or not, but I'll tell you, it almost never precipitates in Antarctica. There's two reasons. One is it's very, very high pressure. It's terribly cold. And the coldness means the air can hardly have any moisture anyway. So all it really does at the South Pole is snow very, very lightly. And then the snow that's already on the ground, which is like 2 miles thick of solid ice, just blows around a lot. At the North Pole, which is the ocean but frozen over most of the year, it also barely snows, sometimes a little bit. Mostly it's pretty dry. So this is largely true. Now, the first thing I want to do to complicate matters is to admit that we have seasons. The Earth's axis being tilted 23.5 degrees like this, means that, like if I'm the sun, look, northern hemisphere gets summer. Now, southern hemisphere gets summer. Clearly, this whole scheme I came up with, about the equator being hot and making these cells like this is kind of predicated on the idea that the equator is going to be the hottest place, getting the most sunshine. But that varies during the year. That the sun's overhead rays on June 21st don't fall on the equator. They fall at about 23.5 degrees latitude, about there. That means the intertropical convergence zone, if it's really going to be under the direct rays of the sun, so it kind of should do that, would have to migrate. It would have to migrate up. Maybe at first thought you might think it'd migrate up to 23.5 degrees north in June, and maybe you think it'd migrate down to 23.5 degrees south in December. However, it takes time for land or water, especially water, to heat and cool. And the poor ITCZ gets kind of pulled one way and the other. It's just too slow to respond. It's kind of like over here, northern hemisphere says, come up here. Hey, you ITCZ, come up here. It's like, oh, okay, all right. And then all of a sudden it's like, no, come down here. Oh, what? So the ITCZ can't go that far. It strays a little bit though. It strays about 5 or 10 degrees either side of the equator. So sometimes you'll find that this is supposed to be the ITCZ. Sometimes they leave the Z off. But it ranges up to about here and down to about here. So it drifts a little with the seasons. And so do the other lines. I don't know if they drift exactly the same amount, but roughly speaking, the horse latitudes head a little north in June. They don't go too far, but they're average about 28 degrees north on average during the year. In June, with the sun more sunny up north, everything's shifting northward. I think the horse latitudes probably make it to an average of about 35 degrees north. In December, they make it down about as far as maybe about, I'm going to kind of guess, about 22 degrees north. So they vary several degrees either side of their average place. And you can also say that for the subpolar low. In June, the subpolar low really is way up in northern Canada or something, like 64 degrees north maybe. In December, it can come periodically pretty well south. Sometimes it even flirts with us here at about 34 degrees north. Mostly it's like, 50, something like that. So these zones migrate. What this means is it throws an interesting, fascinating complication into who's wet and who's dry. For example, let me pick a place. I'm going to pick a place. You've probably never heard this place. I don't know if I can spell it. I think. Nailed it. Ouagadougou. That's really a place. People actually live in Ouagadougou. It's the capital of its country. Can you guess its country? I'll give you a hint. The country used to be called Upper Volta. Didn't tell you much. It's now called Burkina Faso. Yeah, I'll show it to you. Anyway, it's a country in Africa. I actually met somebody from there once. And I thought I was going to impress him by like saying, "Oh, are you from Ouagadougou?" I thought he would say like, "Oh, you know the capital of my country, bless you." No, he just said yes. I guess everybody thinks they know where Ouagadougou is, right? Everybody thinks everybody does. Anyway, let me tell you about Ouagadougou. Ouagadougou is 12 degrees north of the equator, roughly 11 or 12 degrees north of the equator. So what's it like to live in Ouagadougou? I didn't ask the guy, but I know anyway because I understand this stuff. You see, I don't know everything about living in Ouagadougou, but I do know this. Ouagadougou is on the border between a wet place and a dry place. It's close to the ITCZ, so it ought to be wet. But it's also close to the horse latitudes, so it ought to be dry. And the horse latitudes and the ITCZ don't stay put all year. They move. Think about it. I'll let you think a little bit. What time of year, what month, do you think Ouagadougou gets wet? You could pause if you really wanted to think. Time to tell you, Ouagadougou's wet in June, July, maybe August. When the ITCZ comes up to pay a call, the ITCZ comes north and kind of gets pretty much over Ouagadougou in the summer, following the sun's rays. And then in the summer, Ouagadougou, which is always warm because it's not far from the equator, is wet. They have afternoon thunderstorms and sometimes even rains at night. It rains like about 10 inches a month or something like that, like at least half the days it rains. Pretty soggy and muddy and green and whatever around Ouagadougou in the summer. But come winter, for what it's worth, I say winter, it's a little cooler. It's a little cooler, especially at night. Who comes to pay a visit? Uncle Horse Latitudes. I'm thinking like, that relative that visits you for a couple weeks each year. I don't know. Maybe you have that, maybe you don't. Anyway, Uncle Horse Latitudes comes down to visit. You're sort of migratory relatives here. And then it's dry. So Ouagadougou has this very distinct pattern because of where it is in this global pattern of moisture, where it has distinctly wet summers, where it rains and rains and rains most of the summer, and then it gradually gets drier in the fall. And then winter is warm because it's not far from the equator, but very dry. It gets real dry. In fact, actually, sometimes they go like 2 months without a drop of rain. And it really gets pretty bad drought around there, but they're used to it. The plants are used to it. They learn how to like soak up the moisture when they got it and like make it through the dry season. Ever heard the dry season, the wet season? We don't know those things too well here in Atlanta. We don't really have strong, dry, and wet seasons. It rains some in every month. But there, yeah, summer wet, winter dry. Book says that. I said that. Now, if you go to the equator itself, it's really kind of interesting. Are there wet and dry seasons at the equator, at the ITCZ's average position? Again, are there wet and dry seasons? And if so, when? I'll let you think. Awesome. And we're back. At the equator, the ITCZ passes directly over you a little after the equinoxes, because it's always lagging a little bit behind, but sometime along about, say, early April, maybe again in early October, the ITCZ is passing through town, coming through town, maybe wants to spend a few nights with you or something, mooches off you, whatever, and it hangs around for a little while and rains on you a bunch. So it rains a lot in like March or April, and again in September, October, it rains a lot at the equator. But at both solstices, it's kind of off over there, and you get a little bit of a break. So yes, indeed, places like Nairobi or something, Kenya, will get 2 pulses of rain, basically, roughly April, October. In January and July are relatively dry, but not, it's like it doesn't ever rain in those months, but it rains a little bit less because the ITCZ is not right on top of your head. What about at the horse latitudes? Now, if you were right smack dab in the middle of the horse latitudes, 25, 28 degrees from the equator, it's pretty much dry all year. You might get a chance, just a chance, that the ITC should come up and rain on you a little bit, maybe at the height of summer. And there's a chance that the subpolar low and the westerlies might come down and rain on you a little bit, maybe in the winter. Most of the year, though, you're pretty dry if you live around 25 degrees latitude. Then there are places around 35 or 40. What if you live around, say, 38 degrees from the equator, either north or south? And 35, 38, something like that. Then think what happens. In the summer, old Uncle Horse latitudes who went down to Ouagadougou, in the winter, in the summer he comes up to his summer place up north, like where you are. It's June, July, and Uncle Horse latitudes is kind of getting into the area here, hanging around the house. And Uncle Horse latitudes is a high pressure system. He's dry. So you're going to get dry summers. But in the winter, Uncle Horse latitudes goes down to hang out with Ouagadougou, make them all dry for the winter. And meanwhile, you start getting flirted with by the subpolar low. May not quite get on top of you, it gets close. It drags little cold fronts and stuff through, and it rains. So this is a climate where you have dry summers, as the book shows, and wet winters. And oh my goodness, are there ever places like that? That's the way life is if you live in the around the Mediterranean. In Italy, Greece, the Near East, Israel, along through there, maybe even along the northern coast of Africa, Algeria, along through there up into Spain. Those areas, around the Mediterranean are right around that latitude. And they classically have those hot, dry summers, sun shining all the time, people at the beach. In the winter, it's a little nasty. It rains off and on. It's not too bad, but, frequent rain in the winter. That's life in a Mediterranean type climate. Now, they generalize the word Mediterranean climate to include a lot of other places. California definitely has a Mediterranean type climate, because if you know about LA, San Francisco, up through there, that's where they get really dry summers. It very rarely, but occasionally, but rarely rains in the summer. But in the winter, it rains, not a whole lot, but some. They get winter rains that have to get them through the summer. It has to snow in the Sierra Nevadas so they can use the melted snow through the summer, store water and everything. That's a Mediterranean climate. Anybody else get it? I'll tell you another couple places. Western Australia has a Mediterranean climate. Chile, Mediterranean climate. You might be noticing some places I'm leaving out. So it's interesting that not every place you think should have one does have one. this kind of area here, like much of South Africa, especially the western part of South Africa and some of Namibia, that area has a Mediterranean type climate. Now, of course, their seasons are opposite. So down there, let's see, winter is in July. So it's wet a little bit in July. If you go down to like South Africa and like Hannah, you remember, it does rain in South Africa in July. Some doesn't rain much there in December or January. It's pretty dry there, especially the western part. It's just a little different for some reason. Now we can take it further. We will take it further. If you went up to the subpolar low itself, up around 60 degrees, it's kind of wet all year. You're always near the subpolar low. It might be a little off one way or the other, but on average, it doesn't make a whole lot of difference what time of year it is. You're going to get some rain or snow. You get to the poles themselves, ain't no subpolar low coming up there. It's just dry. So dry, I'll say it, and you can look at the book. Dry all year. Wet all year. Dry summers, wet winters. Dry all year. Dry winters, wet summers, wet most of the year. A couple of pulses of it. There, I've explained what ought to happen, but it's not quite what happens. If you look at the book on page, let's see, what page is it? Got it. If you look at the actual pattern of rainfall there on whatever page that is, you can see it. If you look at the actual pattern of rainfall, it's not quite what it should have been. It looks like the theoretical thing on the west side of continents, but exceptions get made on the east side of continents. Maybe you noticed an exception already. Atlanta breaks the mold. Yeah, we're different like that. Atlanta is different because you'd think we'd have a Mediterranean climate with dry summers and wet winters. In fact, that's not quite what happens. We have pretty much same all year round, kind of medium wet all year round. Now in the winter, we do get rain because of the subpolar low coming down for a visit in fronts and the westerlies and stuff like that. So we get that active weather and periodic rain in the winter for sure. But our summers fail to be dry. And the reason they fail to be dry, well, a couple different components to this, but you know we get afternoon thunderstorms. They don't happen because of some crazy massive weather system usually coming through. Occasionally a tropical storm or hurricane comes up this way, but mostly it's just hot. And it's humid. And when it's hot and humid, the air gets unstable in the afternoon and it rains on you. So any place that's warm and humid can generate afternoon rain from the heat building up. And that happens on the eastern sides of continents for reasons I'm going to talk about. I better talk about it right now. I will. First of all, this cute pattern here is something we left out, something super important. This ain't quite so because of land versus water. See, it's all messed up because you got like, North America, and, South, well, I didn't do that very well. South America, continents all over. I know better maps than that, you know that. But anyway, so we got continents, land versus water. And since land and water heat differently, this throws a wrench into the whole pattern. The pattern is pretty much true in the southern hemisphere, where if you look, it's pretty much water. There's a little Antarctica and there's little pieces of other continents and, of course, Australia, but that's mostly water. It's kind of uniform. So the pattern I talked about up here is largely true in the southern hemisphere. Look at the northern hemisphere. It's about half land, half water. And that breaks the pattern up in a way that I probably need to Zoom with you some to try to clarify this. I'm going to say it and try to get it across, but it's a little bit complicated. Let me show a local example of this, kind of classic example. So here's the east coast of the United States. Here's Florida, like that. And we live here. And we're at about latitude 34 degrees. And you'd think we'd be in the horse latitudes, and we kind of are. So especially in the summer, we ought to be in the horse latitudes. And there is a big old chunk of horse latitudes right off in the Atlantic there called the Bermuda High. we ought to be in a big old belt of high pressure. But you remember that high pressure tends to form where it's relatively cold. Not necessarily absolutely cold. It might even be fairly warm. But relative to your surroundings, you're relatively cold. If you're relatively cold, the air shrinks down, more air flows on top, you got kind of high pressure. If you're relatively cold. Now, I'm not saying that out in the Atlantic around Bermuda is exactly cold in the summer. It's not. But it ain't as hot as land is. So what tends to happen is instead of there being continuous high pressure all the way across that zone of latitude, instead you get a focusing effect where the isobars kind of go like this, and you get a strong high pressure system, 1,024, 1,020, and so forth, over the ocean, because the ocean is kind of, for that time of year, kind of cold. And it tends to be lower pressure over the land. And you know low pressure tends to make rain. So first of all, the pressure is a little bit low, but there's more. The clockwise, high, north, the clockwise circulation around the high, look what it tends to do. It tends to drag warm, moist air up over hot land. And hot land. And when it gets hot in the afternoon, you got plenty of moisture available to bubble up in afternoon thunderstorms. Furthermore, a couple more things. As air heads north, it tends to converge toward the poles, and as it converges, it kind of like doesn't have room anymore, and some of it pops up to make room for other air as it gets more crowded. Like imagine everybody in the world who lived at the equator trying to go to the North Pole. They'll try to go to the North Pole. They start like getting crowded the closer they get. And some of them have to jump up in the air to get out of the way. I don't know. Anyway, some air rises because of that. So these multiple factors do that. There's more. If the air is circulating around high pressure like that and blowing across the water, you know what it's going to do, don't you? It's going to drag water along with it. So you're going to get a current of water. That's the water. That's a current of water going up the East Coast. That's called the Gulf Stream. It's a river of warm water that goes up that way. It's going to come around this way, and you know, I probably ought to change its color, because over here, it's been up north and becomes a cold current. And I should put some more places on this map. I'm going to put, I don't know, Spain, Africa, England over here. So look. There's a warm current that goes as far as like England or something. But then by the time it gets flowing south again, it's kind of relative to the new places it's visiting, kind of been up north for a while. It kind of got cold. So there's a cold ocean current here. Warm water heats the lower atmosphere, increases the lapse rate, maybe up to maybe paddock lapse rates, maybe makes the air unstable. So there's a tendency for warm surface here due to warm water to make it unstable over here. Whereas over here, it chills the surface, cools it down, makes it stable. You know what? Cool, stable air ain't going to rain on you much. Warm, unstable air is. So in other words, what happens is this effect of the rotating high pressure out in the ocean, driving ocean currents in circles around like that, is going to tend to make west coasts be great examples of Mediterranean climates, but east coasts kind of break the mold. And this is also true in China. You'd think that Shanghai here would be, Mediterranean climate because it's at the right latitude for it, but no. They have a high pressure system out in the ocean and low pressure over the land and a big flow up out of the south. And it makes them have wet summers. It's wetter in the summer than it is in the winter there. So again, we've just talked about some things that break the mold, but there's more. Except that this video has just almost reached its full length, and I'll have to report more later. So maybe this is going to be a 3-video chapter. I'll assign the homework. Should be probably by the time you see this. Anyway, one more video to go on this topic. Bye.